In Watered Down, we are going to learn how to perform dilution calculations, understand what dilution is, and essentially we're going to understand that diluting a solution decreases the concentration of that solution and can make a solution less acidic or basic. We should also understand that dilution cannot change an acidic solution to a basic solution or a basic solution to an acidic solution. First off, let's discuss what dilution is. Dilution is a process to decrease the concentration of a solution by adding solvent. And normally we discuss concentration in terms of molarity, which we should be very familiar with by now. By adding more solvent. Now, our normal solvent is water. Okay. A key thing, we're not changing the concentration by removing solvent or adding solvent, or adding solute. So we're not changing the amount of solute there. And the formula we're working with here is M1V1 is equal to M2V2. Now, M1 is our initial molarity, our starting molarity. And V1 is our starting volume. M2 is our final molarity. And V2 is our final volume. Now, you probably have seen this in algebra when you're talking about inverse relationships. So, as you can imagine, if I'm increasing the volume of a solution, I'm decreasing the molarity. So that's an inverse relationship. Why does this work? This works because moles are constant of solute. Now remember, our mole triangle, molarity triangle, molarity is moles over liters, so when we have up here in our formula, molarity times volume, molarity times liters is equal to moles. So, our moles are staying the same, we're just changing our volume, and that's why. So, let's do some molecular modeling of this here. So, let's consider here. We have 10 milliliters of acid at a hydrogen ion concentration of 0.1 molarity. Now remember, so the pH of this solution is going to be equal to negative log 0.1, and that's equal to 1. So, get a little pH review in here as well. Let's say I add 90 milliliters of water. Well, I'm starting with 10 milliliters of water. That's my initial volume. If I added 90 milliliters of water, I would have a total of 100 milliliters of water. That would be my final volume after I diluted. So the process of dilution is just adding more solvent. So adding more solvent causes the dilution. And I want to know what my final molarity is going to be. I know my initial molarity over here is M1. And I want to know what my final molarity is going to be equal. Well, I can just set up my relationship, my M1, V1 is equal to M2, V2. I can just plug these values in, or I can substitute those values in. So my M1 is going to be 0.1 molarity, moles per liter. My volume 1 is going to be 10 milliliters, equals my molarity 2, which I want to solve for, times my volume 2, which is 100 milliliters. And I can solve this algebraically. I divide both sides of the equation by 100 milliliters. Notice my units cancel out. And I get my M and my hundreds cancel out. And I can calculate that value. 0.1 times 10 divided by 100 is equal to 0.01 molar H plus. And let's, an interesting note about this, you can calculate the pH. Let's do another pH review. It's equal to negative log of 0.01. And that's equal to 2. So notice, I changed my volume by a factor of 10. I multiplied my volume by 10. My molarity is 1/10. But because pH is a logarithmic scale, only changed my pH by 1. Referring to that factor of 10. So moving on, there are some limitations to this because water always has some acid and basic. It can act as an acid or a base. And you'll remember this equation that we talked about here, the molarity of acid, H+, times the molarity of hydroxide ions is always equal to 1 times 10 to the negative 14th. So, and this is because pure water has a pH of 7, the minimum molarity in that of hydrogen ions is 10 to the negative 7. The minimum hydroxide ion concentration is 10 to the negative 7 as well. So we can never, ever, you can never dilute an acid to be basic. And you can never, likewise, dilute a base to be acidic. So if you have an acid, you can never dilute it. It has to be less than 7. And you can dilute a base to greater than 7. You'll never get to 7, but you will approach it. That's it. So we'll be doing this lab soon.